Well, hello friends. Today it is my 35th birthday, so we are going to do something fun for that, and it's going to be making a web server for Serenity. So a while back, somebody filed this bug here about running SerenityOS.org on Serenity. Now, that's a pretty cool idea, but I think it's a little bit ambitious for a single video, but we can get started, right? So let's make a simple web server that can take some HTTP requests and serve them to the browser on my host machine, let's say. Right, so let's start by just making a web server directory, and maybe we will serve files from www, and let's make a little index page, just something to test with. Web server start page. I don't know, just something nice to show up there. Got it. Actually, kind of works. If you are reading this in a browser, I think we may have succeeded. Unless, of course, you just loaded the local file in your browser. Cheater. Okay, now that's a very serious test page, so let's save that, and then we can create some files here. So I guess we want like a main file, and then we want some kind of object to represent a connected client, and maybe that's okay. And then we'll just grab the telnet server makefile, because and just edit that a little bit. So I think that should be enough setup to move to the editor. Okay, so what's the first thing that we're going to do? We'll include that client class, and then we'll get libcore event loop, and we will make a TCP server, and we'll probably also need TCP socket. Okay, let's put this in a namespace, like that maybe. And I'm not sure what to do with the arguments right now, so we'll just leave those. And let's make an event loop. Okay, and now we want to listen for HTTP requests. So we'll make a TCP server. And we will say that when somebody connects and we are ready to accept the connection, then accept, say we assert that we get a client socket, and then we will make a client object. So client, wait, this doesn't go into web server namespace. What am I thinking? Web server client construct, and we'll pass in the client socket, and we'll do something like that maybe. Okay. And then finally, we will just listen on any IP address on port 8080 maybe, or maybe 8880. I don't know what we're gonna listen to. 8000. 8000 is pretty cool. Okay. And then let's go and define this client class. Namespace web server. Let's inherit from core object, And we will actually need TCP socket here because each client is going to have a socket. Okay, and TCP socket. Okay, and then we'll need a constructor that takes a non-null ref putter to TCP socket. Make that private, and why is it indenting like that? That's so weird. Oh, okay, maybe they're missing semicolon. It's a bit weird, but I guess it's okay. Then we needed start, and then maybe start will just like accept the connection, set up a callback, and then the callback will be something like we'll handle the request as a byte buffer, and maybe we'll have something like send response with a I don't know, we can make an error response at least. And error code, something like that. Well, it seems like a pretty decent class for this. Okay. So client non-null ref putter to core TCP socket. We'll start with that one. And we will have to call, maybe we should parent these to an object so that somebody owns these things. And we don't have to manage that ourselves. Okay, I think we'll do it that way. Then we'll say that you parent these to the server. Okay. Then we'll have client start, which will do something, and then we'll have client send error response, which will do an error response. And okay, so when we construct one of these client objects, I think we can just say, well, let's do nothing in the constructor actually. So we'll do msocket on ready to read. That just means that we are ready to go. So let's say like that, and then request is read all. And then if request is null, then we should have some way to end the request. We'll just do like a die or something like that. If the request is null, then we just die. And in order to die, we just have to unparent ourselves. So that would be simple. Okay. Now, but if you do get a good request, then we can say handle request move request. Okay. This is a raw request, I suppose. Now we'll want to turn this into a more useful object. So we have in libcore, we have the HTTP request object. Now this I've never used this. I never constructed this from like parsing an actual incoming HTTP request. It's just this is what we use in our HTTP client code to make outgoing HTTP requests. So you sort of construct one of these objects, and then here's an example, right? Like you create one, and you set a URL on it, and then you can make the request an outgoing request. But now we want to use the same object and parse an incoming request into this object. So that'll be new, but I think that will make sense. So it will be something like request or error, maybe. HTTP core, HTTP request, from raw request. Raw request has value. So if it doesn't have a value, we'll make an optional out of it. So here we'll just say send error response, maybe. Or should we even error if we can't read the request? I think maybe not. We'll only send an error if we wait, let's always die. We don't have to do any kind of fancy multiple requests per connection stuff. Let's always die after a request, so when we return from this function, we die. So then request or error value. Okay, and now we have an HTTP request, so we should be able to like got request. Maybe we'll do it like this, got request. Request dot, oh wait, it doesn't know what that is yet. Let's go and define something here. Static, that'll be pretty cool. Okay, so here we'll just say method name, so it'll be like get, head, post, or whatever. And then the request, and the URL. I guess we won't have like a full URL, but like the resource. Because I think, so an HTTP request usually starts with a string like this, right? Like get, index, HTML, something like that. And then this is the method, this is the resource, and this is the protocol version, I guess. And this is the really interesting part right now. So let's parse that out to be the resource. Yeah, and then maybe we can dump out all the headers as well. So request headers. Maybe we don't have a way to see the headers, but we should. We'll do something like header name and then header value. Yeah, there's no headers thing and no resource thing. We'll add it. And send error response. What's that even going to do? I guess something like strong builder. HTTP. Wait. How does this look again? I have to cheat. Let me connect to my local web server and say get and this is what it looks like. Okay, so something like, and then the code, and then the message, something like builder append message. And we can even do like a little stupid HTML page here at the bottom so that we get something in the browser. And let's see, what do we put there? Getting really serious here. Builder append view code builder append message. All right, and then we'll just write out the whole thing. That'll be our error response. Okay, and then I guess we can just always respond with an error at the moment. So send error response 500 internal server error, bro. Don't have to be so formal. Okay. Now let's go and flesh out that HTTP request class, because I want to be able to see the resource, not just the URL. So we'll put this here. And let's also add headers. So, and headers can just be like a name-value pair. It doesn't have to be fancy, but just something like this, right? It's pretty good. And oh, and let's expose those. So like this. Okay. Now we are going to need a request parser. So this is a response. I guess the requests, they actually look very similar, but let's just see what kind of requests we would get. Let's collect one. So first, I guess we should make sure that this whole thing gets installed. So we'll just we'll call it WS maybe for short for now. And we will simply install it like that. Okay, now I want to dump out a request like I was saying, right? So, oh, right, that's not going to compile yet. There we go. Request as a string, maybe. There we go. No? Oh, wait, I'm too far ahead here. Let's just dump it out of here. Got raw request. And we will put some little single quotes around it so that we can recognize it. Ugh. Okay. From raw request. Well, seems like I didn't implement a lot of the stuff yet. Okay, just let me build. Jeez. Just let me in. All right. And actually, how are we even going to talk to the web server? We're going to need to add a forwarding here. So forward port 8000 on the host machine, say, to the machine inside on port 8000. Okay. And then we'll run the web server. And then we will, I guess, see if we can connect Firefox to it and see what happens. That's pretty cool. So we got our internal server error, bro. And here is our request. So let's save this for a little prosperity. Can we please save? Cool. HTTP request from Firefox. Okay, then we got a little bit of TCP implementation telling us that it's not quite finished, but we can just ignore that for now, I think, because we were able to connect and get a response. So that should be enough to build a web server, at least to start building one. So we gotta parse this, right? So we have a line containing a method, a resource, followed by a protocol, and then a new line, and then it's all name, colon, space, value, repeating until we see a double new line. Oops. Or really repeating until the end. So it's pure. I think maybe we can turn this code back on. And we will go in HTTP request and start fleshing this out finally. From raw request. And so let's see. I want to find like a little parser state here. So we had, wait, why did I lose that thing already? I wanted to look at it. Let's put it always on top so we can see it. Okay, so we have a few states here. So first we are in the method, and then we are in the resource, and then we are in the protocol version, and then we are in header name, and then we are in header value. Okay, and the first state is in method. Okay, and then we can say for int I, as long as we have some characters. All right, how do we want to do this? So I guess we can do peek and consume. So peek is int offset if index plus offset is greater than or equal to raw request size, then return null byte. Otherwise, return raw request at index plus offset. Oh, do something like that. Okay. And this will just give us back the character currently at index. So assert index is less than our request size. Oh, I think you have to put one of these actually. Okay. Then here we can do while index is less than raw request size. Okay. Switch state. So we'll need a buffer to collect all of these things. Give it some space here. Buffer. Maybe I don't need this. So if peak is, or we can actually collect one character. So consume one. If ch is, wait, hold on. New lines are, in the HTTP protocol, new lines are CRLF. So it's like, it's actually like this. It's two byte new lines. So we have to detect that, I guess. So we'll say like peak 0 is R and peak 1 is N. Then we know that we have a new line coming in. So if is new line, then we will come, wait. There's no new line in the method. If peak is space, maybe we should do that. Consume, and then method is string copy from the buffer. So we'll collect all of these like this. Headers, and we'll have like a current header or something like that that we can collect into. And then the state will advance here to state in resource. Okay. So this is actually kind of weird. Right. So then the state, if we are in resource, then we advance from in resource to in protocol. Assign to resource. We're not going to handle every type of request here, so we'll not. I think we'll not handle malformed requests. Certainly not in this video, but we can at least just kill the connection if something comes in that looks weird. So in protocol. Buffer append, consume. So here we'll advance to in header name. Looking for that new line. Okay. I'll need to consume twice to eat both of those bytes. Okay, otherwise it's pretty good. And then in the header name, we can do both here. So in header name, we wait for a colon followed by a space. So we'll consume those and put this into current header dot name, move on to value, And in header value, we're looking for a carriage return line feed. Consume those, copy it into the current header value, and then move back to header name. And of course, appending the current header to the set of headers that we are grabbing. Okay. And finally, oh, and let's say that if for some reason, oh shit, wait, we have to clear the buffer after we do this. So something like this. Method is, oh wait, method is an enum, I think. Yeah, so if method is get, so we had get, head, and post. There are more methods, but we're not going to implement all of them right now. So we'll just say we can tolerate those, and otherwise we will just fail the function, and then we'll say request resource is resource, and request headers is headers. And I was thinking maybe we'll do something like if buffer size is greater than I don't know, some number that I don't like. Say you can't have more than 64 kilobytes of buffer here. Fix me. And figure out what the best limitations should be. Appropriate. Just so that we don't allow someone to come here and just use up all the memory. Okay, so this was a little bit repetitive, so let's just maybe like commit and advance to, we would commit to method and then advance to state in resource, something like that. And then that would be like advance to be like output and new state. That's kind of good, because then we can just say like commit and advance to state in protocol. I want to commit to current header and name. Current header value. State in header name. Blum, blum, blum. Wait. Commit to this guy, commit to that guy, but then append the current header, right? Okay, this feels like a vaguely decent way of doing this. So let's see if we can run this. Oh shit, I need to recompile libcore. Wouldn't it be nice if that just worked? Okay, so we have our HTTP request get / and these are our headers. That's pretty good. So it's asking for a connection keep alive, but we're not going to implement that. We're just going to respond with some very basic, like HTTP 1.0. You get like a single response, and then we disconnect the socket. But I think we can commit this as a patch of its own, so we'll just say liquor. Allow constructing a HTTP request from a raw HTTP request. This patch as a very simple HTTP request parser that can be useful for implementing, say, web server. But it could be useful for implementing not just a web server like we're doing now, like a web server, but also if you wanted to put like a little HTTP server into an app. It would be cool if we had the infrastructure to do that, right? So that you could potentially like instantiate a simplified HTTP server and then set up some like callbacks on it so that any app could potentially like just expose some part of itself over HTTP, and then you could open your browser and go into the app's web pages. I'm not really sure what we would do with that, but there is potential there, I think. Like just making a quick and simple way of throwing up a web interface to an application. Okay, so back to this client thing. So what are we going to do here? I guess we are going to look at the request type. So if it's GET, then we will, if it's not GET, then we will fail. If request method is not, then I think we'll fail maybe with forbidden. And then let's figure out, let's look at the resource that you're looking for. So I think maybe we will we'll disallow like .. and stuff like that, just to be on the cool side here. So for now, we don't have to do all of the path sanitization, but we can do a little bit. How do we want to do that? Maybe we'll use the file system path class, actually. Because file system path knows how to collapse all of the .. So canonical path. If we do this and we construct it from the request resource, then requested canonical path. I just want to see what this would look like. String. Wait. Let's just see what this looks like when we run it. Oh, wait, hold on. And requested canonical path / right foo bar. pretty good. We can work with that. And then what if we connect to it like this, and we do some sneaky requests, like // internal server error. Whale. Why did you not like that? Requested canonical path /. Oh, right. So that's good. That's pretty good. I think we can work with that. Then let's say string builder, path builder, and we'll put everything in dub like we said before. And then path builder append, canonical path. And we'll need to open the file. Construct path builder to string. And if we can't open it, so if read-only open fails, then we will fail with a 404. Not found, bro. These error codes are very friendly. So let's see. But if we do find it, we'll say if we do find it, I guess we just have to start giving a full response to this client at this point. So it'll be something like 200, okay. And then comes the content type and all that jazz. We want like the content encoding, I'm thinking. Content encoding. Is that the name of it? Shit, I forget. Let's go to my local Ubuntu machine here. Just see what the responses look like. How do I see the headers? Response headers. There we go. Content type. Okay. Content type. Oh, we can say what server this is. That's cute. Let's do that. Server. Web server. On SerenityOS. That's awesome. And I think the last thing we do is just do one of those again. Because we don't need to do the date and stuff like that. We could do the content length, I suppose. But we could also not do it. So we don't need that one anymore. And now we just need to send the file read all. It's probably not the most optimal way of doing that, but it'll do the trick. So let's see it. Not found, bro. Wait, why does that not fail? Hey, look at that. That's pretty cool. So this is us talking to the web server. Very awesome. That's really nice. Let's print something out. So send OK response. We'll put this in an OK response thingy. So file read all. And oh well, actually, let's not get carried away with that. But I was thinking we could, in the error response, we could log something. So we could say like printf. And we could say like what was the code that we ended up sending. So like code, and then the wait, we need to match this up to the request. We got send error response. We'll pass in the request so that it can print something based on it. So that, and then that. Maybe we'll put the current time here, something like that. I don't know. I just want to see the requests on the standard out when we're running the browser in the terminal. So this will be the time right now. And then we'll have the code, and the request method name, and the request resource. Okay, then I guess we'll need time.h. Be good to build some kind of time object, or date time or something like that in libcore. Because, you know, the Unix timestamp is not the fanciest thing, but I don't want to make a local time object right now, so. Here we'll just say const HTTP request. We'll just forward declare it. All right, and then if something goes well, we'll log that here too. So we'll say like, the code in this case is 200. Yeah. Log response. Response. Log request maybe. Or log response is nice. Code request. Okay, and then it's a bit weird that when we went to like the root, then we just got an empty page. I would have expected to get like something different. I wish I had a second terminal. Not sure what for, but I wish I had them. So, oof. Okay, that's cool. Bar. Not found. And see, we can see the response here. That's pretty cool. So what if you go to slash? Let me say 200. Why does that succeed though? Because we never told it to open index.html. Are you just opening? Wait. What does open do? you opening a directory? Just a little bit weird. I would have thought that opening a directory would fail with like eIsDear. Path name refers to a directory. We still allow you to open a directory unless you want to write to it. Wait. Oh, wait, is that what POSIX says? What does the almighty POSIX say? Just gotta look this up, and I guess we can look at what we do. So, in the VFS open, we only check isDear if you're saying that you want to write to it. So you can open a directory file for reading. Okay. Interesting. Well, we should. Do we have fstat? Yes, we do. Okay, so we could fstat it and verify that we haven't just opened a directory. At the same time, it would be kind of cool to do those directory listing things. So I don't know. But right now, let's just say that we will give you index.html if there is one. So if file, can we get stat is directory? No, there's no such thing. We'll add that then. And then we will try to open how do we do this? Do like do we need stat? It's not MFD, it's FD, okay. We'll say if that fails, it's probably not a directory if we can't fstat it. And then otherwise we'll return s isDear of stat st mode. All right. So if it's directory, we will path builder append index.html. It's a little bit strange of an API because then we'll open twice. But see, this is awkward, right? So maybe we'll do the stat here. So if core file is directory, we can have a way to ask for it like this: path builder to string. This is clearing actually. There's no real need for string builder to string to clear. I can just get rid of that. I feel like that might break some tests though. Did not break a test. I feel like that should be tested. We don't have a string builder test. Okay, well, one thing at a time. So make string builder to string non-destructive. This was an artifact of an earlier design of a string builder where I had attempted to avoid to preserve the same allocation from build to final string. Anyways, it's just getting in our way now, so we can do something like this, and then if it is that, then we will do path builder append index HTML. And then we need a static variant of this as well. Which is a bit of a strange thing to suddenly add, but I guess I kind of like that. So this will be file name, string file name. String view is a bit annoying here because we would have to null terminate it to pass it to fstat anyway. Stupid fstat, or lstat rather. And no, we can't. We have to pass it to stat. Or lstat? Lstat is fine. Stat. I think it's okay for that to follow the symlink. And, oh, right. Something like that. And then that will work. And now we have to rebuild a bunch of things apparently because why? Oh, because I changed file.h, of course. The core file is directory helpers. Yeah. I feel like maybe we could improve this page a little bit. Congratulations, or we'll say web server, SerenityOS web server, start page. Congratulations. I don't know. Oh, right, we have to actually start the server. Oof. That's really nifty. And then if we try to go to .. and everything, all of those paths will be just mangled down by the file system path code. It's not going to leave any .. unresolved. That's pretty neat. So what if we wanted to put some other page here? We could like add a link. I'll use p tags instead, because why not? P. Here is a link to another page. Say, try this link to another page. Server other page. Holy moly. This is not even index HTML. How neat is that? Maybe you want to go back to index HTML. Okay. Making some real fancy web pages here. So I'm going to try these out. So, poof. It works. We're on another page. How neat is that? How neat is that? Let's go back. All right. So, that's a pretty cool little thing we got here. So I wonder if this would work from our own browser. I feel like that's not going to work because we never really tried connecting, or I have never tried connecting to localhost. Wait, what the heck? Localhost over HTTP. Host unreachable. We got a raw request. Get slash host local host. Why did we get host unreachable? Get host unreachable and we try to write to it. Why do we get told to route our packets to nowhere? Why? That's weird. I'm just gonna put a little logging here to see. Oi. Here is that. Local is. I'm just curious. This might be a bigger issue to debug here, so I'm not going to spend too much time on this, but I can't reach localhost from localhost. Well, that's clearly not right. Why does that fail? So this should definitely be 127, right? So we should be returning the loopback adapter. And a routing decision should have the loopback adapter and no next hop. But it says that it's 0 and adapter is null or the next hop is 0. Well, the next hop is 0. Wait a minute. If we are sending something to ourselves, man, I'm context switching into networking code suddenly. It's been a while. So obviously, if we want to send something to ourselves, then we don't have a next hop. So I think it's okay. So if we have an adapter, I think we should fail if we have an adapter, but if we, yeah. I'm not sure about this, but if we know which adapter to send a packet out on, then that should be enough. But we could also, what do we do with the next hop? Because we could also say that like next hop is just the loopback adapter. So we send it to the next hop. Okay, all right. So back up. Let's not change that, but let's instead change the way that route returns the loopback adapter. We'll say loopback adapter the MAC address. Okay, so the route to localhost will now give you the MAC address of localhost. I think that's sound. Okay, why not now? Wait, what? Host unreachable. Okay, wait. Give me that debug code back. I can't get it back. Frick. Unreachable. Local address, and then we had one more host unreachable. That's this one, and then in TCP socket as well. Connect host unreachable. Oi. It's doing that, so we'll just do that. Why is it unreachable? I don't understand. Okay, connect host is unreachable. Localhost 00000. Okay, so our local address is this. Route to. Wait, what is the type of this thing? It's a U8. And what is the MAC address of this thing? Does this interface not have a MAC address? Ooh, look at that. It has an empty MAC address. Okay, what does Linux do for that, I wonder? Can you see what the hardware address is? I don't know how to interpret this data. Ether. Maybe it's a bit weird to give a MAC address to loopback interfaces, but I think let's just give one because a bunch of the code relies on it. So set MAC address. How do we construct these anyway? Just like this. Okay. I don't know. Put some, since it's my birthday, let me put in my birthday. So 1985. Happy birthday to me. And then we will put some cool digits at the end, like those cool bit patterns. No? Okay, so we got the request. We're sending presumably a response right here. But then the load fails. I wonder why. Anyways, so much stuff happening now. Do we have anything that we want to change here? Host under. Let's just leave those. Let's take out these annoying messages, but we can add a NAT, give the loopback adapter a MAC address, since the routing code currently relies on putting a MAC address. Currency interprets an all zero MAC address as an invalid route hop. Invalid next hop. Let's give the loopback adapter an address. And then routing. When routing to loopback, use the loopback adapter's MAC address. Otherwise, the routing decision be interpreted as host unreachable. Gets interpreted as host unreachable. This or this, this or this, this or this, this. Okay. Now we are paring down to the web server stuff. So I guess we can add the web server now. Base dub. And I think we'll commit what we have, so web server. Implement a very basic HTTP server. This server listens on port 8000 and serves HTML files and data. Yeah. It's very simple and quite naive, but I think we can start here and build our way to something pretty neat. I guess, where's that bug? SerenityOS.org. I should say that this is work towards that. Work towards 792. Did this mention? And of course, a web server is going to help too. Well, it's damn right, Dan Void. Web server is going to help. That's why we're making a web server. So let's see. So now this web server runs pretty unrestricted, which I don't love because it's listening to TCP connections, right? So let's do a little bit of pledge and unveil here. So let's see. We can do a pledge. We can pledge at the very end, actually, before we hit the event loop. So we want to pledge standard I/O, accept connections, read files, and I was thinking iNet, but we don't need iNet because we're just going to set up a listening server, but we don't need any more than that. So if this fails, pair pledge turn on. And I guess we need SerenityIO for pair, right? And then we'll also unveil dub for reading. If that fails, and then we will close ourselves off from the outside world. Okay, let's see if this can still run like this. So that would be way better. They work. And let's take a look at our web server. It's running right here. So only the www directory is readable to this process now. And you can only do standard I/O, read files from this directory only, and he can accept incoming connections but not make any outgoing connections and stuff. That is pretty tight. Very, very nice. Okay, so I mean, we could do a little bit better job here by also pledging initially as well. We could pledge. We need a few more things while we're constructing the event loop and stuff. So we'll need inet, Unix. But we need cpath and fatter, I think. And can we still get up and running? Yes, we can. Okay, that's good. Web server. Tighten things up with pledge and unveil. The web server process will now only run with very limited access. Will now only be able to read files in www. Well, we don't have to say, but it's pretty awesome. If you're not familiar with pledge and unveil, they are these security mechanisms or mitigations from the OpenBSD project that I have also started to implement in Serenity, which I find them really awesome. If you're not familiar, you can actually read about them on my blog, which is here, which I recommend checking out if you want to learn about these, because they are really, really cool mechanisms. And I always take every opportunity to tell people about them. So I think we're pretty good there. Maybe take one more look at that issue with why doesn't it work in the browser inside Serenity? But it might be like big trouble, so I don't know yet. But let me just make a convenient link for myself here. Localhost, let's say. Okay, and then I'm just a little bit curious why this doesn't work. So if we try to go to localhost, gotta start a server, then it fails. Here. So what is the protocol server doing at this point? Do we have any sockets open? No, we don't. And we have protocol server, and what's he doing? We can't see it because we are not protocol. So let's get a root system monitor and take one more look. not doing too much. Protocol server. You know what? I'm not gonna get into this now because it's gonna prolong, or it's gonna extend this video forever. So let's just instead enjoy what we have built, which is this fantabulous little web server. So this is pretty awesome. Very happy with progress we were able to make here. So I think the lesson here is that the TCP implementation needs more work, but at least we're able to serve requests, which I'm super happy about. So this is going to be the end of the video today. So if you made it this far, then I thank you for watching, for hanging out, and I hope you saw something interesting here. And thank you for hanging out and for coming back. It's really great to have so much company when I do my little hacking projects. So I really, really appreciate the company. Thank you, everyone, and I'll see you next time.